All pretty good there? Okay. Guys, pretty simple stuff today, honestly. We're going to talk about a certain type of form of an equation. We're going to talk about some of the characteristics that help us graph that equation, and then apply some of this stuff to real-life settings here. Guys, 3.4 is titled Graphing Linear Equations in what we call something very important in math here a lot, standard form. So I want to tell you that right here, graphing something in standard form is really what we're looking at. And I'll show you what the standard form is in a second, but essentially, how can you describe the graph of the equation ax plus by equals c? This form right here is considered standard form. And I'll show you some examples here in a second. But some of the goals that we're going to try and hit today to answer this, volunteer to read my first goal. Go, T.
Graph equations of horizontal and vertical lines.
Okay, horizontal and vertical lines. Horizontal being what type of a line? Left to right, flat, right? And then vertical lines are just going to be something that would be straight up and down, right? Okay. Somebody new read that second one for me. Thanks, Em.
Graph linear equations in standard form using intercepts.
Intercepts. Specifically over here, I'm just going to jot down using x-intercepts and, whoops, using x-intercepts and y-intercepts. And there's a really nice shortcut for that. I think you'll catch this right away. And then lastly, we want to use linear equations in standard form to look at real-life problems. So vocab-wise today, we need to understand what standard form is. Standard form up there says it's a linear equation of the form ax plus by equals c. Here's an example. The idea being here that a, b, and c represent some number. Okay? Basically, this is saying you have 3 of something plus 2 of a different thing. They total up to 24. If I had to ask you guys to identify the a value, the b value, and the c value in this example, what is my a value up here? 3. What's the b value? 2. B is always going to be next to y. And finally, the c value out here by itself is 24. Right? Guys, we're going to start using that form to help us form graphs. 2 points that are going to be very important for us today are going to be what's called the x-intercept and the y-intercept. The x-intercept is going to be the point of the graph that crosses the x-axis. So if you have a graph that looks like this, this point right here would be considered the x-intercept. It's where that graph crosses the x-axis. It's where the graph crosses the x-axis. So that point would be considered my x-intercept. So if the x-intercept is the point on the graph where it intersects the horizontal axis, what do you think a definition of y-intercept is going to be then? It's where it crosses the y-axis, or in other words, the vertical axis. So again, if this is my coordinate plane right here, if this is my coordinate plane, and this might be my graph right here, say something like this, the y-intercept would then be the point up here where it crosses the y-axis, all right? Okay. So again, everything that we're looking at today is going to be linear. We're just going to have a different form. I want to show you how this works today. Got a quick front-loading question. This ties in nicely with standard form. I want to volunteer to read my front-loading question here. Thanks, Emily.
You have $26 in $5 bills and $1 bills. What are the possible combinations of 5s and 1s to total $26?
How much money do we have? $26. So 5s and some 1s. All right, so I'm going to make a table. I'll make a table right up here. Guys, give me a combination that would work to total $26. 3 5s.
Oh, wait, no. Wait. 4 5s.
4 5s and
That's
5
5 times.
5s.
Yeah.
All right. It's been a long week, hasn't it, Dee? Okay, so 5 5s you say? 5 5s. What's that you say? 5 5s. And what else? 1 1. That'd be $26, right? Another combination that works. Well, our 10s are optional. Just 5s and 1s. I agree 6 1s would work. 3 5s, 11 1s. Kaylee, you have a different one? 4 5s, that's $20, and 6 1s. I agree. How about 2 5s? 2 5s would be $10, right? Could I do 2 5s and 16 1s? And then how about one $5 bill? How many ones would you have to have? I want to show you something right here. I'm going to order this way. I'm gonna put the 5s in order from least to greatest. Let's see, if I had 1 5, we had 21 ones, right? If I had 2 5s, we had 16 ones. If I had 3 5s, we had 11 ones. 4 5s, 6 ones. Check this out, guys. What's my change right here from the 5s? Each time I go up to the amount I have. 1. How far down does this drop each time? Drops down 5 each time, right? Are all those changing y's over changing x's going to be the same right here in this example? Does this type of real life situation model a linear equation then if those rates of change are the same? Okay. So this would be an application right here to say, hey, this is linear right here, okay? So I want you to kind of think like this right here. This is an example where we're going to start talking about standard form. I'm going to put an equation up here for this. Guys, we don't know how many ones we were going to have. So I'm going to say the numbers of ones that we had might have been X amount of them, okay? What do you think we're going to call the number of 5s in? If X represents the 1s, what do you think is going to represent the 5s? Well, Y, okay? Guys, in standard form, to form an equation in a situation like this, here's what you would do. Again, you've got some 1s and 5s. So each $1 bill is worth how much? $1. How many 1s do we have? Which variable defines that for us? So an expression for the amount of money I would have in $1 bills would be 1 times what? So I would write this as 1x. We've got some 1s right there. To that, we're going to add in some. Each y is worth how much? So an expression for the amount of money in 5s would be what times what? So we're adding in some 5s. So 5 times how many ever 5s you have. In this case, y. Totally, we want that mess to add up to how much? $26. Well, I will be. Doesn't this look like it models something like ax plus by equals c form right here? What's the a value in this? What's the b value? What's the c value? That's all that's going on here. And that's what standard form is. That's how standard form is represented linearly. Basically, you're comparing two different quantities of different values, adding them together, get a constant out here on the end. That's all that's really going on here, right? So you understand how standard form ties into a problem like this first one. If I had some 20s and some 10s, and I said I have $110. I have some 20s and some 10s, and I have $110 total. What would be an equation in standard form to model that situation? I have some 20s, I have some 10s, to total $110. What would an equation look like in standard form to model that? 10x plus 20y equals 110. You get it? All right, good stuff. Let's go to page 2 quickly. Now guys, standard form is going to start talking about some things that are going to involve vertical and horizontal lines. I'm going to kind of go away from the way that they definitely explain what vertical and horizontal lines are and show you some shortcuts today. Guys, example 1 starts talking about graphing a horizontal line. In other words, it's a line that runs from left to what? Left to right. So some rules about this. Horizontal lines always cross which axis? Well, take a look at this line right here that I've drawn. Right up here. Take a look at this. Which axis does that line cross? Crosses the y-axis. Okay? And it's also going to take on the form of y equals some number. Well, guys, look at these 2 points that define this line. It is horizontal, isn't it? What point defines this here? What is this first point? -3, 3. What's this point right here? 2, 3. Let me ask you this question. What value up there on the y-axis does that horizontal line cross? 3. The y values are always going to be what value? The y value was 3 here. The y value was 3 here. What's the y value going to be clear over here? 3. So an equation for this is to say, hey, well, I crossed the y-axis horizontally at what value? There's the equation for that line. Y equals 3. I'm going to put one down here. I'm going to try and trick you. Horizontal. Y equals -2. There it is. Okay. Pretty easy, isn't it? Pretty easy. Well, guys, if horizontal lines cross the x-axis, what are vertical lines going to cross then? Which axis is this vertical line right here in blue going to cross? This vertical line crosses which axis? Okay. What's the x value in this point? What's the x value in this point? What do you think the solution or equation for this vertical line right here is? X equals what? Okay. Rules. They run up and down. Vertical lines will cross the x-axis, and they're going to take on the form x equals some number. This vertical line right here crosses the x-axis at what value again? So the equation for this line, for a vertical line, is just simply x equals -4. X equals -4. That's pretty easy. The question about this line right here. Way over on the right. What's the equation of that vertical line? X equals 2. Crosses the x-axis at 2. Okay. If I say, hey, find me an equation of a vertical or horizontal line, can you answer? Pretty easy. Okay? Pretty easy. All right, well then, take a look then at for the next page, I guess. Okay, this is the part right here in example 3 where we're going to start using intercepts to graph equations in standard form. Short little cheat sheet up here, guys. It says if an equation is of the form ax plus by equals c, then what's it say for the x-intercept, guys? C divided by what? Okay, so let me give you an example over here. If I have an equation, 3x plus 2y equals, I don't know, let's go 30. Okay. First of all, you've got to be able to identify your A, B, and C value. What is the A value in this? 3. The B value is, and the C value being 30. So by definition up there, or the rule I'm going to give you shortcut-wise, if they say, hey, I want you to find an x-intercept for this graph, or the point where the line will cross the x-axis, it simply says take C and divide it by what? A right here, right? So the x-intercept right here would equal 30 divided by what? 30 divided by 3, which is going to be 10. X-intercept would be 10. I want you to be careful on the next example I'm going to give you. Y-intercepts. The rule for y-intercepts is C divided by what here? B. Okay, so here's an example. I want you to be very careful on this one. Here's a possible standard form equation. Maybe 4x minus 2y is 20. or x minus 2y is 20. Guys, to find the y-intercept value for this particular graph right here, what is it suggesting we do again? C divided by b. What is the c value? Be very careful on your b value, please. The b value, is it 2 or is it negative 2? Negative 2. So the signs preceding those a, b, and c values, you always take them with. So right in front of the b value of 2, there is what kind of a sign? Okay, so the b value negative 2. So what is 20 divided by negative 2? There you go. All right, so let's apply this. Let's apply this. We're looking now at a situation to graph a line right here, neither vertical nor horizontal. I want to use the intercepts, specifically which intercepts up top there, guys? X and Y to graph this. So do this, guys. Your x-intercept. I'm just going to jot this down again for this graph. Now, guys, right in front of the x, there's nothing there. So the implication is that is how many x? Okay? You got that by doing 6 divided by what? 1. So right here, you're telling me, Jacob, this is really 1x right there, right? And I'm going to jot down A1. Ooh, that wants some steak. All right, never mind. That was bad, I guess. Too early? Too early? All right. B is 2. What's the c value in this? 6. So to find the x-intercept for this particular graph, I would do c divided by a, which is 6 over 1. And 6 divided by 1 again, Jacob? 6. Okay? So what this is implying, hey, my graph is going to cross the x-axis at what value? Okay, so on the x-axis, come over here and plot 6. How much your y-intercept, kiddos? What over what? So what's the definition for finding y-intercept? C divided by b, right? So what over what? 6 over 2, which is? Y-intercept 3. Oh my gosh, you have your 2 points. What are you going to do? Plot it. Okay. Once you've got it, the nice part about it is this then. You already have your graph. And your graph would be the following. Boom, boom, boom. I like it. It's pretty easy, isn't it? What tool could I use to maybe confirm that I'm correct? Decimals. Just type that equation in and see if it works. You know the nice thing about decimals is, if you hover right around the y-axis, it's going to tell you at that point is 0, 3. If you hover around here, it's going to tell you it's 6, 0. All righty then. Questions so far? You understand x-intercept, y-intercept? Yes? Give me some sort of sign that you're alive right now. All right. Well, this last example then. Now, guys, here's the deal. Many times in real life situations, they'll start applying standard forms to them. Just like the front loading question we had in here, we looked at a graphing example right here on the last page with all 4 quadrants. Okay? It was just a general graph. Give me the line of that standard equation, x plus 2y equals 6. That would include all 4 quadrants. But when you start talking about real life situations as it relates to something in standard form, think about the problem we had at the very beginning, some 5s and some 1s. Is it possible to have negative 5s? Can I have negative 3 5s? No. Can't have that. Question, Jacob? Got an answer. All right, I'll come back to you. Let me talk a little bit about this. So, in real life problems, a lot of times they'll only talk about the first quadrant as it relates to standard forms because most of the numbers we work with in real life situations, whether it's time, whether it's money, those are usually what type of values? Positive. So most of the time you're in the first quadrant for real life situations. I'm going to read this quickly. Jacob, I'll come back to you. It says, you're going to the fair. Woohoo! Have $16 to spend. Oh, that's not a lot. On rides and games. It says ride tickets cost how much, guys? $4. And game tickets cost $2. It says the equation for x plus 2y equals 16 models the situation. You understand this equation as it relates to the $4 rides and the $2 games now? You can have so many rides at $4 a piece. You can play so many games at $2 a piece. That sum can only total up to the amount that you have. How much? Well, 16. X is the number of ride tickets. Y is the number of game tickets. How are you going to graph this, Jacob?
On the y-axis, it's 8, and on the x-axis, it's 4.
Why on the y-axis am I 8?
Because the 16 divided by the 2 is 8, and then the 16 divided by 4 is 4.
So this is my c divided by a, c divided by b. Is that correct? Everybody agree? So the x-intercept would be 16 divided by 4. Boom. Right there. 16 divided by 2 is how much? What was it again? 8. So the y-intercept is going to be 8. Now a graph of this right here is only going to exist in the first quadrant. So you're going to have a start point and an end point. I'm going to draw this quickly. All right. All right, so again, what does x represent? What's the x-axis down here representing? X is the number of what? Number of rides you can take, right? All agree? And y is going to be the number of, number of game tickets, I guess, or games you can play. All right? Now, this is an interesting problem. I went ahead and drew a continuous graph for this right here. But guys, is it possible to play 3.5 games? So down there below it says find 4 possible solutions in the context of this problem. In other words, we're taking something that's continuous, and we want to find basically things that are discrete. I can count the number of games and the number of rides I can possibly be on. I can't be on 1.474 rides. If you're on 1.474 rides, something went horribly wrong somewhere in that ride, right? Okay? You don't want that. What we do want, though, is this. We want the points on the line that hit whole numbers. So isn't this first one right up here a whole number of, or a point 0, 8? You guys agree with that? So I'm going to put this down here, 0, 8. What this implies is this. Guys, if x is 0 right here, how many rides did I ride? 0. How many games did you play? 8. So if I don't ride a ride at all, I'll just play 8 games at $2 a piece. Is 8 times 2 my $16 spent right there? It is, right? Follow this line down right here. Oh my gosh, I see another point that I hit. What's this point? All the way around. 1, what? This would imply on the x. I could do 1 on the x and do one ride and what else? 1 ride plus 6 games. I can do 1 ride plus 6 games. If I follow this down again, don't I hit another point right here? At, what's that point, guys? What's that point? 2, 4. Which would imply how many rides? 2 rides and 4 games. All right. What's the next point that we get if we continue to follow that line? 3, 2. 3 rides plus 2 games. Finally, what's the last one? Well, let me even just do this. Do you guys even see a pattern in these points I picked out here? Where are the x's going up by each time? 1. How far down are the y's going down each time? 2. So the next one has to be 4, 0. Which one would I say? Oh, we're just going to do 4 rides. 4 rides I would do 4 rides. I'm not a gamer. I'm a rider. All right, here, this would mean to play 8 games, right? Okay, so you understand why the only place that I graphed that was in the first quadrant. You play negative games. You ride negative rides. No. So you see why they just keep that within the context of the first quadrant? Okay. A lot of real life problems that relate to standard form are always going to be graphed or represented graphically in the first quadrant. In which case, once you find those points, that's going to kind of answer your combinations that you can have. Kind of like we have with 5 and 1 and stuff. What do you guys think about this? Pretty good? Okay. I'm going to go ahead and stop it here. You guys have